So with that in mind, I'll quickly jump into a quick introduction. So I'm Shivay. I'm a first-time NDC speaker as well, and I've been trying to apply for a long time. So I'm super excited to be here in Sydney. It's my third time in Australia and third time speaking at a conference in Sydney. So kind of a love relationship with Sydney, and I absolutely love the city as well. And in terms of just my credentials as someone who has worked in the AI space for the last 6 years, I was greatly involved in my previous role at Couchbase, which is a vector database. And today I'll be speaking a lot about RAG, right? How many of you have now at least come to understand what RAG basically means? I see more number of folks here working on that. But building agents and vector search solutions at Couchbase for the last 2.5 years. In fact, like I've been involved with the vector search space ever since 2023, when one of the most earliest open source frameworks came into being. I'm also Dr. Captain, and you can usually, outside of work, you'll find me either traveling or you'll find me at a karaoke. How many of you were at yesterday's karaoke? Only just a couple of folks. Okay. So you can always reach out to me about my favorite karaoke songs. I wanted to start off with an analogy. Like, why am I showing a picture of the, how many of you recognize this picture? That's the Harbour Bridge, right? Now, it's a great bridge. You get very good viewpoints of the Opera House, and anyone can walk and anyone can drive. But has anyone tried to jump off or climb the Harbour Bridge, or has probably considered doing that? So you typically need a permission, right? You cannot just directly go and say, today I'll jump off. Of course, no one should do that, or I'll climb the Harbour Bridge. You need proper permissions to do that. And similarly, when you're dealing with LLM systems or agentic systems, your agents should not just be able to like do whatever they want. You need to have proper guardrails or security in place for them to be able to make certain decisions happen, right? A similar example is Bondi Beach. How many of you have been to Bondi Beach so far? A few folks. Similarly, like Bondi Beach, it's one of the most beautiful beaches. I did the entire walk, about 3 miles, and you'll probably find that on this pristine clear water where you can swim, there are still certain points, right? And the lifeguards, they will always look at, you should only be swimming in that designated area. You cannot go beyond that because of the high tides, right? So again, this is a security or a wall that has been put in place by the system where you cannot just do whatever you want, right? Or you can only do things in that limited access. So I wanted to showcase these couple of examples, real world examples, to really talk about what I'll touch upon in today's talk, which is how do you add guardrails or security boundaries around what or what cannot your agent do, right? So I hope that these real world analogies helps you to kind of understand what we'll talk about in today's talk. Now, we have already seen a huge shift in terms of how we are interacting with AI applications. So in fact, like when you talk about neural networks, the building blocks of today's LLMs or multi-language models, those concepts come all the way from the 1950s, 1960s, right? There is a lot of research being done on how we can use the processing power that we have in the neurons of our brain, but apply them for computer-based operations. But we really saw a huge influx of these deep learning models with one of the first original papers that was published around AlexNet. How many of you were probably like around that time exploring AI models back in like early 2010s? Not a lot. That's completely fine. But it is like the beginning of the neural network era as we speak, right? And of course, came in 2022 when ChatGPT was launched and we had officially GPT-3, right? How many of you were early adopters of ChatGPT when GPT-3 or GPT 3.5 came about? I see very few folks. When did all of you start using ChatGPT? Like 2024, 25? Okay. So the idea is that the model that was powering ChatGPT in 2023 was actually accessible via an API in 2020. In fact, like I was in university at that time, I was already using the official GPT-3 API back in 2020 way before it was generalized to the public. And the reason it really blew up was that now people did not have to write custom Python programs to interact with AI models. They had the ChatGPT interface. But that quickly jumped on. There are so many different open source models that came about. And today we are like in a situation where GPT 5.5 was just launched yesterday, and it's already like beating a lot of the benchmarks. You're now seeing these LLMs not just generating text, but they can generate images, videos, and whatnot, right? And they also have built-in agentic capabilities. So now you don't have to just build a separate agent altogether. A lot of these LLMs have built-in tool calling. So they are much more versatile when it comes to like being able to do agent use cases, right? So we are moving very quickly and we are iterating very quickly, at least like when we talk about a research. Now, whether or not we are actually like seeing adoption at the same scale in enterprises is probably a different discussion, but we are gradually like moving towards a very quick adoption of these LLMs. And of course, agents are really changing the way that how we work. So this is a quick summary of what you can do with agents today, right? So when we spoke about Gen AI, it is these specialized AI models that can generate content for you. But then you had to give them a text-based prompt and they would give you a response. But agents are much more autonomous in nature. You can make these agents also work in the background where they are not just reliant on a human input, but they can actually plan, they can decide and also act. Now, of course, there are like two different ways that you could interact with agents. One could be a human in the loop, where the human is still required for the agent to do certain action. And that is always required or recommended, like especially if you're working with more security focused applications where you don't want the agent to just randomly make a decision for you. And you can also now do completely autonomously things where the agent does not need human intervention and it can just do things on its own. Now, that's typically a design choice, again, based on organization, based on what your intended use case is. And finally, like RAG is the way for LLMs to get over the hallucination problem, where it can interact with documents on which it is not originally trained. So these would be typically things like your internal information inside of your organization on which an LLM was never, or a public LLM was never trained because it's not public information. And it can give you relevant responses based on your data. And we'll touch upon more specifically around RAG use cases. And of course, gradually also touch upon how you can control your agents and secure whether or not they should make a specific tool call. But of course, when agents are so versatile, why do not we see every single organization just jump into that particular bandwagon, right? So of course, I was exploring how many few folks have actually implemented agents in production. There were like very few folks. And there is a good reason for that. There is still a lot of vulnerabilities. In fact, like the CEOs of top companies have basically raised their concern around some of the security implications, right? And in fact, like in just the last few days, we have seen some massive security problems raised by Lovable, raised by Vercel. How many of you are aware of those that happened, right? In fact, like with Vercel, it was one of the employees just gave access to an AI tool that led to a vulnerability in their Google workspace, and that led to a lot of secrets being released. And again, had we had proper security guardrails with how these AI systems work, probably that could have been averted. But there's a good discussion point here why we need to have proper authorization and authentication for security systems. So that is why this talk today that you will be countering is more of a security talk rather than an AI talk. So AI agents are powerful. They are getting more and more access. So how do we reduce the risk? How do we reduce the attack vector of potential attack agents that could compromise your agents, right? So that's the most important thing that we'll talk about today. Now, how many of you are aware of the OWASP? It's a foundation that generally talks about security risks from an application development point of view. But over the last couple of years, since late 2023, they have been talking about Gen AI risks, because if you compare a traditional application, there are certain differences between a generative AI application versus a traditional, web application or a desktop application. And some of these, if we just summarize, I'll not jump into too much details about these. You can always go and explore what each of these basically mean. But with LLMs, your most important security risks are things like sensitive information disclosure. So what that means is that the LLM should not disclose certain private information based on a user's query. So it should be aware what are the roles and permissions of a user, and depending on the role. So for example, if a finance person in your company is trying to access information regarding your private API endpoints, it should not just do that. Now, if you don't have proper guardrails, the LLM would not just care which user is asking for the information, and it will just go and query the data for you, and it will give that data. So of course, that should never be the case. Some of the other things like system prompt leakage, if you have taken part in one of the challenges that's happening downstairs, there's a prompt injection. You must have probably heard of these terms like model poisoning or prompt injection. So these are much more hardcore security challenges that are just specific to AI models, which are also massive, massive security risks, right? And hallucination and misinformation is another one. So if, like, let's say if you're in a legal or in a investment company, if you have hallucinations, that could probably have detrimental impact on your company's business. Because if you're giving illegal legal advice or illegal medical advice that is completely just hallucinated, then of course that could have massive risks to your customers, to to hospitals as well, potentially, if you're using AI inside of healthcare data. So you need to ensure that the systems that are in place, they are secure, but they're also being verified, right? So these are some of the massive challenges that we see. Now, for ML engineers, of course, like a lot of us are software engineers, we are not going to be concerned about the last four that you see, right? Prompt injection, supply chain attacks, data model, and model poisoning, and misinformation. These are for ML engineers and ML researchers. The ones that are highlighted in red are the things that we as application developers can control. And that's in our ballpark to basically take note of, right? And the one that we'll focus today specifically for this talk is the sensitive information disclosure, because that's the one which is the most concerning and one of the more easier ways to deal with, and something that you can deal with when you're actually like designing your data model for your application, right? Now, every single GenAI agent should basically address these four security concerns. And this is something that you should also take into consideration when you are probably at the system design architecture or thinking about what your application looks like and you're planning to apply an agent to it. The first one is always verify who is making a particular request, right? Because by default, an agent would not just know who is making that particular request, right? I gave you the example of a centralized knowledge base for your company. So imagine that all of the documents of your company, including expense reports, including sales data, profit information, endpoint related information from your engineers, all is existing in a single workspace. So an intern who is a financial intern should not be able to access information about the historical sales related data of the company, or they should not be able to get access to the Salesforce information about competitors or your customers, right? So always verify who the user is and who is interacting with the agent. Then second is that sometimes the agent can basically make calls or API calls on behalf of the user. So you should probably have proper permission checks that, okay, what are the systems that the agent can deal with or can interact with? And usually it's like a top of the funnel, that the user has all of the permissions, but your agents should not have all of the permissions. It should be more task oriented, that based on the task that the agent is supposed to do, it should only have access to those n number of things that it can actually do. Then third is that agents a lot of times can also work asynchronously, right? So if you have AI driven workflows, you should always have proper visibility into what the agent is basically doing, and what are the steps involved in that workflow, and how the agent is interacting at any point in time. And finally, the most important one that we'll focus on for today's talk is enforcing data access control. So the AI must respect all of the permissions for specific resources that it basically accesses, right? This is probably the most important, because if you don't have these proper data access control, some attack vector could use your agent to be able to retrieve private information that we'll see as an example. So for today's talk, we'll focus on the sensitive information disclosure. And this is like really relevant for companies or for use cases where you have a lot of private information. And what I mean by that is that, let's say you have a lot of information that is kind of bounded by different layers, right? So for example, certain set of users might only have access to certain information within the company. So those type of use cases, right? So an example of this could be that agent can only access a company's public records unless it is explicitly authorized to be able to get access to the private information. And the agent should not be able to just go ahead and modify your existing records. And at the same time, an agent should not be able to access confidential records or records belonging to other employees. So this basically, ties back to the example that I talked about, which is a centralized knowledge base. And in fact, like the example that I've built specifically for today's talk will touch upon this centralized knowledge base as well. So the question is that, like, how do we enforce this at runtime for an agent? And the answer to that puzzle is authorization. So that is why, I mentioned at the beginning that this particular talk is more of a security talk rather than like a full-fledged agent or an AI talk, right? So we'll touch upon the next few minutes and really jump into different type of authorization models. Just a quick vote of hands, like how many of you know about ReBAC or role-based access control? So quite a lot of folks. And how many of you have actually implemented APIs where you have applied ReBAC principles for backend systems? So see, again, quite a lot of folks. So let's talk about how authorization or access control basically evolved over time, right? So for this, I'll take example of coffee. I would imagine a lot of folks love coffee here. If not, that's completely fine. But you see here different grains of coffee, like you have full-fledged grains, and over time you're seeing that the grains are smaller and smaller and they're much more fine-grained, right? So you'll understand what I mean by that analogy. So this is basically 1960s, 1970s. At that time, before we had ReBAC, we used to have these access control lists. So the idea was very simple, that you would basically ask a question like, does Kate have read access to this particular file? So it is as simple as that. You had limited number of users, you had limited number of applications, and the only question that you were trying to address is, does this user have access to this particular file? That's it. Then came in ReBAC. So here you basically applied a role, or you assigned a role to each and every user. And let's say your company had 5 different roles. So you had the role of a product manager, you had a software engineer, the CEO, the CFO, and maybe an intern. And now what you would basically do is that, based on all of the information or what a particular user can do inside of your organization, you would basically assign a role to it. And this simplifies things for you. So based on the role that, okay, a product manager can do these X, Y, Z tasks. If you assign that particular role to a user, then that user has access to those particular tasks. But one of the concerns with ReBAC is that, let's say if your organization is very big, something like a Microsoft or a Google, you'll probably have N number of roles, like 100+ different roles within that org. So of course, like maintaining access control based on this ReBAC or based on the role assigned to a user can become very complex. So as your company's or organization's size increases and the number of roles increase, complexity dealing with role-based access is not really something that scales very well. And that is why we call them as coarse-grained authorization, where you're just leveraging one single attribute on the basis of which you're assigning roles and permissions for your data access or a particular assignment that a user can do. And that is why, with the analogy of the coffee beans being more fine-grained, we'll talk about that how we solve this problem with the help of fine-grained authorization, where you're not just limited to one single attribute, but rather you can use multiple attributes to do certain things. So as a natural successor to ReBAC came in attribute-based access control. So the idea here is very simple, that to a single user, you're not just like assigning a one single attribute, that what was the role of the user, but rather you can have things like what is the role of the user, what are the working hours of that particular user. So here you can ask questions like, is Kate part of the product management department, and is Kate having, like, let's say XYZ working hours. But you could go much more deeper as well. You could go into, does Kate have permission to eat food from the cafeteria? Something like as arbitrary as that. But you can really just define what levels of attributes or what kind of attributes you want. And that is why attribute-based access control is like far, far better. How many of you attended Heather's talk yesterday? So there she really, dived into attribute-based access control and how it's a far better example as compared to ReBAC, right? Now, the great thing about attribute-based access control is that it gives you a lot of accessibility in terms of like how you define permissions for your security. But then there's still this one, not security concern, but one drawback that is probably arguable. But let's say that your company has a very complex way in which your documents have been stored. Let's say that you have like the parent folder, and then you have a subfolder, and there are some subfolders inside of that subfolder. So you have multiple layers of subfolders. So imagine that now a user is having access to the parent folder. They also have access to the subfolder at level 1, level 2, and level 3, but they don't have access to the child or the 4th level document. So if you think of this as an access tree, you have access till the 3 layers, but you don't have access till the 4th layer. So what that means is that with attribute-based access control, you have to make DB calls to 3 levels only to find out that, hey, this user didn't have access to that document that's at that 4th level of access, right? Which means that you just wasted a bunch of database calls only to realize that the user didn't have access. So, I mean, of course, this is a bit more niche, but these will be the kind of things that you'll run into where you are probably like running a lot of unoptimized DB queries unnecessarily just because your data access, the way that your data has been designed in your company was designed in a way which felt a bit more lacking. So in order to circumvent these type of niche use cases with ReBAC, again, don't get me wrong, ReBAC is really great. And in order to address the challenge that I just shared with you, comes in relationship-based access control. So it's essentially a natural successor to the ReBAC strategy. But here, the idea is that based on the permissions, based on the objects, the users, and the kind of things that they can deal with, we basically create a graph, a relationship graph. So if you are aware of the graph theory, like, you have vertices, you have different, nodes, and then all the nodes are connected with different vertices. And this way you can define like different type of relationships. So with a relationship-based access control, you can get very detailed type of request or detailed type of answers that you can basically get for your data. So you can get access to things like, okay, is Kate in the product department? Is the roadmap document inside of the product folder? And does the product department have viewer permission to that document? So when you have such complex type of questions that you want to answer, what would basically happen is that you don't have to define all of the security related or access related decisions. In fact, like, you just define some of them, and based on the relationship based access control, it automatically creates the relationship graph and already like creates the rest of the access related decisions automatically. So that's the beauty of ReBAC. So in this type of model, you define the certain set of subjects, and we'll have some good examples that give you a better mental model. Like, if you have not been able to completely understand ReBAC, just wait for like a few minutes, you'll get a much better mental model shortly. But in a summary, like what you do is you define a certain set of subjects. So these could be users or a group of users, and a set of objects. So these could be like directories or folders or maybe even tenants. So keeping an example of the knowledge base, your users could be, okay, user Kate, user Rob, user and Anthony, and then or directories could be like, okay, think of a Google Drive like folder, right? You have multiple folders. So of course, certain users might only have access to certain folders within a Google Drive, but they may or may not have, like, let's say, read or write access, right? Some of them might only have a write access, some of them might only have a read access. So when you want to define whether a particular subject or a user has a specific relationship with a particular object, whether it's like a view relationship or a read relationship or a write relationship, all of that just becomes a lot more easy to deal with when we talk about ReBAC. And that is why, like, when we want to ask very complex questions, you can basically traverse this relationship graph, which is formed by these objects, subjects, and the relationship between the different objects and subjects by using this ReBAC strategy. So the question is that, okay, we spoke about all of these different authorization techniques. Which one works the best for AI apps? Answer is ReBAC, and we'll touch upon why that is the case. And again, this is specifically for dealing with sensitive data control or what kind of actions agents can basically do based on the business logic that you have for your application. That is why ReBAC is, according to me, the best approach towards authorization. So talking about an open source project that can allow you to do ReBAC is OpenFGA. Now, this is not just like one example of an open source project, and by no means this is like a sales pitch for this open source project, but this is like one of the n number of open source projects that can help you define ReBAC based authorization model. And it was maintained by Okta, and in fact it has been inspired by the Google's Zanzibar paper. How many of you have read the Zanzibar paper? Okay, not a lot. The idea is that it basically defines like how authorization works at scale. And in fact, like if you have used Google Drive's entire architecture is based on the Google Zanzibar paper, which means that the Google Drive essentially employs a ReBAC style of strategy. And there are a lot of other specialized databases that also work on this particular strategy, like SpiceDB. So SpiceDB, if you're using OpenFGA, they're all based on this principle. And like, if your question is, why should I even care? If you're building a Google Drive style of application, you're probably using a ReBAC solution. And the idea here is that when we talk about this fine-grained authorization, like how do I define these relationships between the data access control for the users, depending on what their role is, what are the different types of operations. Let's talk about an authentication experience without FGA. So you have a user, they use some type of an identity provider to log in and get access to the user data. So for this, they will create an access token, and that access token will be sent to the application. And using that access token, the application will validate and authorize whether the user can basically call an API. And again, whether they want to access the database. So there will be a separate call that will fetch the data from the database, and then the user will be able to see the result. Now let's talk about like what this looks like from, with the example of an FGA kind of application. So here the user logs into the identity provider, they get access, they still get the access token that's sent to the application, but this time you authorize externally with the FGA model. And here the FGA model basically checks whether the user has read access or write access to that particular resource. And if they do have that, then that will be sent back to the user and they'll be able to make a call. So here you have an external check taking place so that your API does not have to do that. You have this separation of concern, which checks for relevant access related data and then sends back the result. And the great thing is that with something like an OpenFGA, you can basically manage all of the authorization for all of the different products by defining your or a ReBAC system. And all of the decision logs and auditing can basically be maintained in a centralized way. So it's very easy to implement authorization for new features that you're basically releasing for your company. So let's talk through how an OpenFGA ReBAC strategy would basically look like. So here we'll first touch upon the authorization model. This is what basically defines how or what are the different things within your authorization model. Then we touch upon what are the different relationships, because again, ultimately you have to realize that we are building this relationship architecture where you go to that level where you can define this user has access to this information and what type of access is it, right? Is it a read or a write access? So let's first talk about like an authorization model here. So if you can see on the screen on the left hand side, we have the type user and we have the type document and we have a type folder. So this is taking an example of a Google Drive like strategy where you want to define that, okay, each and every document will have a parent, right? So there will be a parent folder and every document will also have an owner. And we have another scope that we have defined here, which is viewer. So of course, you can basically say that every user can either be an owner or a viewer of a particular document. And a folder, like if a user has, so here what we say is type user, type folder, and we have a relation, and then we say define viewer, and that is of the type user. So what that means is that by default, if a user has viewer access to a particular folder, they will automatically also have access to all of the documents within that particular folder, right? So this way you can see here that you define that with the relationship of the parent for a document being a folder, that means that every document will have parent folders, and then the owner of a document is the person who created it. I mean, makes logical sense. And then define viewer as user or owner or viewer from parent. So what that means is that a user who is a document viewer, right, and whether or not they have created or not, that will basically define what that interaction or what their access control for that particular document would look like. So this is how you'll generally like define your authorization model. And then the relationship tuples is basically the relationship access that you define. So for example, a user Kate will have, like, let's say a relationship of being a viewer to a folder named product, because if you remember, Kate had the role of a product manager. So that means that Kate can view the product folder. Similarly, we have defined another access, which is a folder of type product. It's under the parent, which is the roadmap. So, the product related decisions will be under the, the product is the folder, but then within the product folder, you have a document named roadmap. And then another example is user John, and they have the access of viewer to the document folder and the roadmap document, right? So document folder, and they have access to this particular roadmap document. And then you define certain access control checks. Okay, so user is David, they have relation as viewer, and they are trying to see an object, which is the roadmap, whether they are allowed or not. So if you say that it's not allowed, then you can define these access control checks based on what your application is, right? So let's take an example here. So this is what we define in terms of like how the authorization model looks like. Then if you say that if relationship is Kate, then basically you can see that that attributes to the type folder, because we were seeing whether the user is having a viewer access to that particular folder. Then if we say, okay, like a roadmap is part of the folder document or the product document, so here we are specifically seeing which particular type of authorization model, or within the authorization model, what we are basically hitting. And similarly, like a user being able to like see the document roadmap is hitting the define viewer type of relationship within your authorization model. And then when we say access control check, so for David, it's hitting again the viewer. Then you talk about user John, whether they have access to the viewing, and that is true because we had defined the relationship that yes, John can view the roadmap document. And for a user Kate, so this is where it gets interesting, right? You didn't have to define that Kate has access to the product folder as well, and they can also view roadmap. Because the idea was that with the help of this ReBAC graph that gets created, some of the role-based access control decisions were automatically created for you because it was automatically inherited, right? So that's the idea, that at runtime you don't have to like define all of the n number of or a million plus checks based on how you define your authorization model and the relationship tuples. The ReBAC graph will automatically create those subsequent relationship access controls for you, right? So for example, for Kate, we only defined one tuple, but then it's automatically inferred that that user Kate will also have access to the roadmap document. So this allows you to like not have to, and it greatly improves the developer experience for your security team as well. So let's talk about a RAG-based knowledge-based assistant, right? So again, I'll touch back on the example that I originally spoke about, which is a centralized knowledge base. A centralized knowledge base that has control over all of your API documents, that has access to all of your sales report, profit reports, HR related documents. And you want to have this centralized chatbot for your company, and you want to apply that an HR should not be able to get access to API level documents or maybe to your financial data, right? But whereas the CEO of the company should be able to access any document, but an intern working with the tech department should not be able to access anything, and they should only probably have read access to the API documentation. They should not even be able to make changes to the API documentation because they are just an intern in their first 1 week at the company. Because you don't want to probably have memes where the AI, the intern just destroyed the entire AWS cluster for your company. We have already seen enough of those jokes, right? So you want to have that level of access. So how does that work out? So this is what our authorization model would basically look like. And the example that I gave was already somewhat similar. So a typical RAG knowledge base at a company will basically have documents organized in folders where you have access controlled at both the levels, at the folder level and at the document level as well. So that is why your model would look something like the one that you see. So that's your authorization model. And you have users, you have folders, and you have documents that belong to a particular folder, and you have all of the different things, right? So folder has owner and viewer relationship, and a document belongs to a folder and will automatically inherit the viewers. And anyone who can view that folder can also view all of the documents. So again, we have already kind of covered all of this. And this is how you will basically end up writing your tuples. So you define like who owns the engineering folder. Beth can basically view the engineering folder because Beth is probably like part of the engineering team. So this way, like you define your relationships or the tuples, and the idea is that with this model, you can define the relationships to define like what kind of control access you have on top of your documents to get that document level permission for much more fine-grained authorization, right? So when we talk about like FGA, this is where you get that fine-grained, like you can get the essence of that fine-grained authorization, which is a document level permission. So that at no point in time, the AI can get some unauthorized access to a particular document that could be so critical for your, maybe like it's banking information. You don't just want an AI to be able to get that unauthorized access, right? So that's what we are trying to do. And there are two different type of pipelines. Now, how many of you understand a RAG, like how a RAG works, or the framework behind RAG? So I'll just like take 1 minute to touch upon that. So in a typical RAG, what would happen is you take a bunch of documents, you create chunks or vectors, and you store them in a vector database. Now, when a user asks a query, you convert that user's query into a vector query as well, and you perform a vector search, right? You get the k number of top documents that match based on their closeness given the user's query, and you get those x number of results, and you show or you append those results to the LLM, and the LLM gives you a response, right? That's a typical RAG. Now, when you want to apply this filtering, right? So the idea here is that the LLM should only be able to access those documents which a particular user has access to. So if, let's say, an intern is trying to use this chatbot and they're trying to access information via RAG, they should only be able to view documents, or the LLM should only be able to fetch the documents that are only viewable by the intern. So there are two different approaches to this. The first one is post filtering. So here the user will basically ask the prompt, what are the financial projections? The agent will now ask the vector search to perform the vector search result, and it will retrieve the set of documents. And here your OpenFGA as an external ReBAC model will filter the documents based on user's permission. So intern should not be able to see all the documents. Let's say our vector search gave us 10 results. It will automatically filter it down to, like, let's say 3 results, because you have document level metadata filtering in your document, right? So like, let's say it's a JSON document. It will have that defined, okay, like this can be viewed or not by this user. And you automatically do that filtering for you, and the agent will give the response, and the agent only sees what the user, that particular user with their role, is allowed to see. But there is another better approach to this, which is pre-filtering. Because imagine that your AI still retrieves all of the documents. There could be an attack vector at that stage that could still retrieve all of the unwanted documents. There could be an attack vector that's like trying to, think of them as like an intern, and they could still fetch all of the documents before the OpenFGA filtering is being applied. But what if you do the filtering before you actually do the vector search? So this is where pre-filtering comes in. So user asks the question based on the user's relationship, what their role is. You apply a pre-filter check, and you basically send that pre-filter check as a filter. So like basically a lot of the modern vector databases and a lot of these open source concepts like LangChain, they have this concept of a pre-filter meta filter. So when you apply a pre-meta filter to your RAG responses, that automatically limits the kind of documents that you can access. So by being able to apply these permissions, right, you would basically tell your RAG system that I only want documents for this particular user ID, or maybe for this particular role ID, and it will only like give me the results in the vector search result that are viewable by that user, and the vector search response will only contain those results, and then the LLM will only be fed that response. So if you talk about like from a security lens, which is better, I would say a pre-filtering approach like is far better as compared to a post-filtering approach. And we'll see an example now. So user John Doe ask a question, what are the financial projections? So that's the user's query. They ask the question, so we apply the OpenFGA SDK to enforce our authorization rules, and that filters a certain set of documents, and we apply as a pre-filter meta check to our vector search, and then we use whatever SDK. Here we are using OpenAI SDK, and we get the response. Now, if you want to play around with OpenFGA, you can go to play.fga.dev, and this is essentially what I was talking about, that you define your authorization model, the tuples, and it automatically creates your ReBAC graph for you. So you can understand logically like how the system basically thinks about your authorization model. And this is what we're basically building. So let's take a look at our example, and then we'll also just jump into the code, right? So this is our Odyssey Access Studio, and before, like, what I'll do is I will disable the FGA. So here what I have is that I have like 8 different kinds of personas. So executive, engineering, finance, product, sales, and support. And we have 6 different type of product docs. So we have like public, internal, confidential, and we have different type of users. So we have all of the different operators. So here we have like Sandra, who is the CEO, lead developer, sales, financial, security engineer, product manager, customer support. And what you see is that we have defined what are the set of documents that they have access to. So like the CEO will of course have access to all the documents, and so that's the ReBAC control that we have defined. But whereas like let's say an intern, so junior developer will only have access to the API docs, or maybe to the core and technical documentation. Now in a or in a non-FGA related environment, let's say I select the persona as the junior developer, right? So I'll just scroll here. So I have a bunch of like prompt questions that I can ask. So like let's say I want to ask about finance question, right? So the user will ask the question, what are the financial projections for this particular project? And it gives you the result. So this is a typical system where I'm doing RAG, and just to kind of give you an idea, let's take a look at the chunks that I've created. So this is all of the different chunks in the database. So we have a total of like 6 documents using which we created the chunks, and this is what each and every chunk basically has. So these are being stored in a local Chroma DB. So Chroma is an open source vector database in which we have already like created these particular chunks. So going back to our demo here, so this is like how it's basically like performing the RAG and giving you the result, right? So now like let's disable or still keep it disabled, and probably go to Marcus, who is part of the finance, and ask it an API related question. And again, you see that it's still being able to access, and this is something that you don't want. So let's enable the FGA. So we apply the authorization model now, and we'll try to ask the same question again, right? So this time I'll ask it the same question, and okay, so this is the public documentation, but let's probably ask it about maybe the system design details. And now you can see that it just says that I don't have access to that particular design information based on the current permissions. So if I select, let's say, the Chloe as the intern, and I ask it about the financial question again, they cannot. But the CEO can basically get documentation about anything that they want. So again, this is a very simple example that we are trying to contrive, and maybe like there is a comparison mode where we have enabled FGA and we want to select at every single user type what that would look like. So if I want to get access to all of the information that I have, including documentation, financial report, you can see that only the CEO can basically get that documentation alongside the finance director. But even the finance director does not have access to the private endpoint information that the company has, right, for the tech. But whereas like if I disable, everyone will be able to access everything, right? So of course, this is not something that you want. So that is why you can clearly see like how FGA plays a very important role. And just jumping into the code base here very quickly, right? So the idea what you're seeing here is that before we apply our vector search similarity search, what we are doing is we are enabling our FGA client, right? And we find or we fetch the set of authorized documents based on that particular user and based on the document ID, right? And once we get the authorized set of documents for that specific user ID, then we filter the results based on that set of documents. So you are performing the vector search. So this example is of that of a post filtering, but you could also do this beforehand with the pre-filtering and apply that metadata that I just mentioned, right? So this is an example of a post filtering where you're basically now filtering the results based on the authorized set of documents, and only these post filtered documents will be sent to the LLM as the added context for your RAG. So again, this is a very simple example from the looks of it, but of course it could, you could make it a lot more customized for your own use case. So I just wanted to like touch upon how things are happening behind the scenes. Now, as we are just left with the last like 5 minutes, I also want to touch upon how you can expand OpenFGA for agentic use cases, right? So OWASP also has defined the top 10 things for agents, right? So these include like MCP hacking, tool poisoning. There was a really good talk yesterday by Heather who touches upon MCPs and tools. So like a lot of concerns just pertaining to agents, and this was published last year by the OWASP Foundation. So what does OpenFGA for agents basically look like? So agents basically require credentials with specific permissions to interact with certain tool calls, right? And the idea is that we want to restrict what an agent can do beyond what their API credentials can allow them. And the idea is that you want to start with an agent with 0 permissions, and you only give them certain set of permissions on what they can do based on per task level. Because today, like, you have task based or a tool based poisoning that can happen. So you want to really like define at runtime what each and every tool or what each and every task and what are the permission boundaries you can set at each and every task level. Because a vector, attack vector could attack at any point in time when you're defining an agent. So this is an example of a task-based authorization model for your agent. So here you define a tool, and you can say define a tool like can call, and that tool might have a particular parameter, and you can define X number of tasks and what type of subcalls that particular agent can make. So here you have like a tuple where you're trying to call a Slack channel. So you have a task that can list all of the different Slack channels for you, but only task one, user with task one can actually send messages to that particular channel. So what you also, that jumps back to our first point that we discussed about the security concerns about agent. Look at the user. What permissions does the user have, right? If the user has permission to only view Slack channels, then we will hit the relationship user task. But if the user also has write access to the channel, then they can make that particular call, because here you'll have a tool parameter which is send Slack message to a particular Slack channel. So here we have a test where can task one send a message to this particular channel, and it can be true for that particular user. So you can apply this task-based authorization within your OpenFGA. And here's a quick example of this in place. So this is like doing agent authorization. So here, I'll quickly run through the demo. So what we are seeing is summarize this particular dev project and post it on the private team channel. So the same. Now, regular agent will basically just go ahead and do it for you, right? But what you'll see here is that now what's actually happening is that the agent is asking the user for the permission rather than just blindly making that tool call. It asks for the permission from the user. So you can basically like create your agent application in a way where if the agent does not have a permission to do a particular task, it requires explicit information or approval from the user to do that for you, right? And only once you allow it for either for that, allow it once, allow it always, or just for that session. So you can define scope for what an agent can do within just that session, within just that one time. And this is where explicitly we are seeing, and you can see like here, like how FGA was declined because we had that check, and it required based on that check, then the permission or the scope of the program was okay, let the agent specifically ask for explicit permission from the user. Now, had that FGA check said, okay, just go ahead and make a tool call automatically because it had the permission, it would not have done this. So for your application or wherever you're using your agent or whatever your agent is doing, you can define these explicit checks for you, right? So this is an example of how your agent can use OpenFGA and can use permission check that I just showed you. The example that I showed you was a very simple example, but that was a real life use case of what that demo would basically look like. So finally, as we have the last like a few minutes, 3-4 minutes left, here are some tools that you can refer. So OpenFGA has a very vibrant developer community. It has a lot of like really great support for multiple languages like JavaScript, Python, .NET, Golang, all of these languages in which you can define your models and you can use OpenFGA. And it has GitHub Actions, so you can automatically create CI/CD pipelines and check for permissions based on that CI/CD. And it provides you a lot of like developer-friendly APIs. So of course, like I didn't have to like manually write my OpenFGA document. Like you can use or update your authorization models, write or delete your tuples that you saw, and update the assertions or the checks with the help of these developer-friendly APIs, right? So it's relatively intuitive to build with it. So just recapping, whatever we did, AI introduces a lot of different security risks. So unauthorized data access, sometimes it will also be like compliance gaps. What you want to avoid is weak or coarse-grained authorization, because that can lead to what you saw in the demo when you don't have OpenFGA enabled and any user can view any information. And that is just an application that is limited by that particular company. An attack vector could get access to unauthorized documents by you doing like a prompt injection attack on your knowledge-based RAG. So what OpenFGA helps you with is makes your application more secure. It makes it also scalable because the ReBAC model can allow you to add authorization model. So the great thing about ReBAC is, and OpenFGA, is that it's not just applicable for AI use cases. Like my entire presentation was around AI agents and RAG, but you can apply OpenFGA for non-AI use cases as well. And it's very developer first, right? So it just allows you to make a mental model of your authorization and makes it super simple for you to be able to build on top. And here are some of the resources. So there is like a GitHub, and in fact, like they have very good documentation around how to apply OpenFGA for like agents, for even for MCP. So I didn't have time to talk about MCP security, but you can also apply like how OpenFGA principles will apply on like tool calls that you can do with MCP. And yeah, here is the QR code for the presentation and feedback. So if you would like to like share some feedback, you can scan this QR code. And I guess like if we have a couple of minutes left, that would be the conclusion of my talk. And if you have any questions, I'll be more than happy to answer those. So thank you so much. And maybe if all of you are fine, I would like to take a selfie, because as mentioned, it's my first NDC talk. I wanted to make it memorable. Perfect. Thank you so much.